With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
In this question, it is given that in the shown experimental setup to study the photoelectric effect, two conducting electrodes are enclosed in an evacuated gas tube as shown we can see. A parallel beam of the monochromatic light fall on the photosensitive electrode. The EMF of the battery shown is high enough such that all the photoelectrons ejected from the left electrode will reach the right electrode. Clear? Under initial condition, photoelectrons are emitted as change are made in each situation of column 1. Match the statement in column 1 with the result in column 2. Clear? Now, this is the experimental setup we can see. Parallel beam of the light we can see. This is the experimental setup. Clear? Now, we can see column first is this and column second is this. So we have to match the column first with the column second. Clear? So how we can match this? So we can see in the column first we can see if the frequency of the incident light is increases keeping the intensity constant, and the second we can see if the frequency of the incident light is increased and its intensity is decreased we can see, and the C we can see if the work function of the photosensitive electron is increased, and the D we can see if the intensity of the incident light is increased keeping its frequency constant. Now we have to see which one is the correct in the column second. Clear? For solving this question we have to use the relation, two relation, and the first relation is what? E into Vs. This is what? Stopping potential. This is equal to maximum kinetic energy. So 1 by 2 m, and we can write V max whole square is equal to, we can write incident energy h nu minus work function we can write. Clear? And the second relation we can use number of photons directly proportional to intensity and the inversely proportional to h into mu. Clear? This. Now, on the basis of these two relations, we have to answer the question. Clear? So now coming to the first part of this question. In the first part, in the column first, we can see if the frequency of incident light is increased, frequency increased. Clear? Keeping intensity constant. So frequency increased. So we can see that from here, frequency increases. Frequency increases. It means we can see from the first relation, kinetic energy increases and the stopping potential also increases. So we can write kinetic energy increases and stopping potential. Vs is also increases, we can write. Clear? So these two will increase. Now according to this we can see P, magnitude of the stopping potential increases, and R we can see maximum kinetic energy of ejected photoelectrons will increases. Yes. So P and R. So we can see for A we can write P and R we can write. Clear? Now coming to the B part of this question. So in the B part we can see from here it is given that if the frequency of the incident light increased and its intensity decreased. Clear? So we can see frequency increased. Again it is given that frequency increased. Clear? And intensity decreased. Intensity decrease. It is given intensity decrease. Clear? Now from first relation we can see frequency increased. It means we can write kinetic energy max. It will increase. Clear? Now this stopping potential also will increase. So Vs we can write also it will increase. Clear? Now intensity decrease. So from here we can say that intensity decrease, it means number of photons decrease. Clear? Because intensity decrease. So number of photons we can see decrease. If the number of photons decrease, we can see saturation current will decrease. Clear? But we can see in the column second there is no options for saturation current decrease. Clear? So we can see that again P and R is the right for this. Clear? So P and R we can write for this also. P and R. Clear? Now coming to the C part of this question. So in the C part of this question we can see that work function of the photosensitive electrode is increased. So work function increase, clear? So from here we can see that work function increase. It means we can see from here, if the work function increase, so what will happen after some time, this h nu is equal to, we can write this. So after some time, we can write this h nu is equal to, we can write work function. If h nu is equal to work function, it means we can write this kinetic energy is equal to 0 and the stopping potential also equal to 0, clear? So kinetic energy 0, and for kinetic energy 0, this implies that V max is equal to 0, clear? Velocity is equal to 0, clear? And we can see this stopping potential also equal to 0 and the V max is equal to 0. If the V max is equal to 0, it means we can see from here this current through the circuit may stop. Yes. So current through the circuit may stop. So Q is the right option for this, clear? For C part, we can see Q, clear? Now, coming to the last part of this question. So in the last part of this question, we can see that this, if the intensity of the incident light is increased, keeping the frequency constant. So intensity increased, clear? So intensity increased, from second relation, we can see that number of photons increases, clear? So if the intensity increases, we can write number of photons. Number of photons will hurt increases, clear? So if the number of photons increases, it means saturation current will increase, clear? So saturation current increase in this case, we can say. So for D part, we can match with the S part, clear? This, clear? So S part we can say. So in this way, we can solve this question. Hope this answered your question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.